Hey, 7th graders. So today we're going to talk about some special equations. Please make sure you're filling in your note sheet as you watch this video. And then just as a quick refresher, an equation, remember, has to have an equal sign. And when you're solving an equation, you're trying to figure out what number could you put in for x that would make both sides equal. So in like this one, if I put a 9 in here, 9 plus 1 does equal 10. So my solution is 9. So you're basically trying to figure out what could you put in for x to make both sides equal the same amount. All right, so we're going to try to answer this question today. I want to know, does every single equation have a solution? Is there always something that you can put in for x that makes the two sides equal? So take a look at this equation, Matt, and let's see if we can write down what it actually shows. All right, so we have an x tile and a 1 tile, and on this side an x tile. So let's go ahead and write on the first side we have x plus 1. On the other side we just have an x tile. All right, if I'm thinking about my legal moves, I'll just kind of draw my line down quick. I know that I can take away an x tile from both sides. So if I did that, take away an x tile, that would cancel, right? So I would have 1 equals, this would cancel too. 1 equals 0. Is that true? Does 1 equal 0? That is not true. Sometimes you're going to see a little line through here, like an equal sign with a line through. That means that's not true. 1 does not equal 0. So basically, that means there is no number that you can put in for x that would ever make these two sides equal. There's no possible number. So when you get to a problem like this, the answer to this is actually no solution. Okay, that's what you're going to need to write. That means there's no possible number you could put in for x. So let's just kind of explore that a little bit. So if you look at this, let's say I put in a 2 for x here. Well, then that would need to be 2. So let's think about that. If I have 2 plus 1, that's 3 on that side. And that side's only 2. Are those equal? No, they're not. What if I put a 5 in for x? If that was a 5 and that was a 1, that'd be 6. And if this is a 5, that'd be 5. They never can be equal because they both have x's. You guys might notice that. But this side is always going to have 1 extra. So there's no possible way they ever can be equal. So the answer to that is no solution. All right, let's check out another one. So on my equation mat, you guys can see I have 2x's plus 2. So over here, you can see 2x's plus 2, and on the other side, 2x. So I want to know, is there a number I could put in for x that would make these sides, both sides, equal? So if you think about it, just think about it a little bit. Let's say I put in a number for x. I put a 2 in here. So that'd be 2, 2. And then there's 2 more, right? This side would have 2 and 2, but it's not going to have the extra 2. So this side's always going to have more. So it can never be equal. So if we show that with our work, you guys know that you can always take away the same amount from both sides. So I'm going to take that away from both sides. Before I do that, I'm going to combine those. So I have 2x plus 2 equals 2x. And we just said you could take away the 2x's from both sides. So I'll show I'm taking away, that's subtracting, 2x's from both sides. So I end up with 2 on the one side and 0 on the other side, right? I have 2, 0. Does 2 ever equal 0? It does not. So this equation has no solution. Again, there's nothing possible that I could put in for x that would make that true because they both have 2 x's. This side's always going to have 2 extra, so that side's always going to be bigger. So there's no way that they'll ever both have the same amount. All right, let's add a couple things to our notes. So here's how you can recognize equations that don't have a solution. Okay, so if you're trying to figure out, well, how do I recognize ones that have no solution? Okay, one way to recognize is if you end up with different amounts on both sides. So if you end up with something like 5 equals 0, that's not true. 5 does not equal 0. It's not true, so you know there's no possible answer. The sides will never both be equal. The second way is if you can't put anything in for x to make it true. So if you realize, like look at this one down here, you have x's on both sides. So if you put a 5 in here, 5 minus 1 and 5, those are never going to be equal. Okay, so that's kind of the second way. Let's look at this one over here. Okay, now this one, it's kind of hard to tell to start with, so I'm going to have to distribute. So I'm going to do 2 times x, which is 2x, plus 2 times 3 is 6. And that equals, on the other side, 2x plus 5. Now, you might notice right away, if you get to this step, that, well, this is never going to be equal, because do you notice they both have 2 x's on both sides? So that amounts the same. But then this side has 6, that side has 5. Okay, so right away, you might notice, well, this is going to be a no solution answer. If you don't notice it, then you can go ahead and take away 2 x's from both sides, and I end up with 6 equals 5. Well, that's not true. So that means there's no answer that I can put in for x. All right, so we're going to look at another special type of equation. So my next question is there always just one solution to an equation? Is there always just one answer, like x equals 5? Or could there be more than one answer? So we have an equation mat here. Let's kind of just see what we have. On the one side, we have an x tile. So I'll just go ahead and write x. And then we have our equal sign. And on the other side, we have an x tile. Okay, and I want to go ahead and solve that. So I want to know, well, when would they be equal? What number would x have to be? So if I just kind of think about this for a second, what if I told you x was 5? Let's see if that works. If I put a 5 here and a 5 here, well, aren't those equal? Yeah, so 5 works. Okay, now what if I told you a different number? What if I said x was 7? So if x was 7, is this equation true? Does 7 equal 7? Yeah, that works. All right, what if I even told you a different number? What if x was -2? If I plug that in, -2 and -2, are those equal? Yeah, there's a lot of answers to this equation that works. There's actually a ton of solutions. You can actually put any number in for x, and this equation will work. So the answer to an equation like this, we're always going to kind of write, is there's an infinite number of solutions. Okay, what that means is there's like so many, every possible number can work. So there's an infinite number of solutions. Now, if you were going to try to solve this and, you didn't recognize it right away, you could draw your line down and you could remove an x from both sides. So if I do that, take an x away from both sides, I end up with 0 equals 0. Is that true? Yeah, 0 does equal 0. So if you ever get to something like this and it's like that at the end, that means there's an infinite number of solutions. Now, just as a quick refresher, this is not for a check. This is when you're solving. All right, so I could put any number I wanted in that equation and it would be true. And again, if I just wanted to show it, I could put 5 in here. 5 equals 5, yep. Okay, I could have picked a different number. I could have put 10 in here. 10, does 10 equal 10 if x was 10? Yeah. Okay, so there's an infinite number of solutions. Okay, let's take a look at this one. So, okay, first thing I kind of see is I should probably simplify a little bit. X plus x. Well, I know that's 2x. And this side also is 2x. So I want to know, well, what number could I put in for x that would make this true? So let's just kind of think. What if I put a 3 in for x there? So if I plugged a 3 in. Okay, 2 times 3 is 6. 2 times 3 is 6. Does that make both sides equal? It does. Now, is that the only answer, though? What if I plugged a different number in? What if I plugged in 7 for x? Okay, 2 times 7, that's 14. 2 times 7, that's also 14. So I get the same answer again. Again, if you ever end up with the exact same thing on both sides, you know your answer is going to be an infinite number of solutions. Okay, you've probably heard of infinity. That means there's like, you can't keep counting, right? It just keeps going on forever and ever. That means there's so many solutions, we can't even list them all. Okay, because every single number would work. All right, so again, here's an answer with an infinite number of solutions. All right, so we're going to add this to our notes. How can you recognize an equation with an infinite number of solutions? All right, one way to recognize is if you have the exact same amount on both sides. So here would be an example. X plus 3, you might see I have the exact same thing on both sides. So no matter what I put in for x, both sides are always going to equal the same amount. Or if you end up with 0 equals 0. Let me give you an example of that. So I'm solving this equation, and I see, well, I should start with my k's. I'll take a k away from both sides. That's gone, so I end up with 1 equals 1, and then let's say I subtract a 1 from both sides. That's gone. I end up with 0 equals 0. If you end up with that, then again, you should know that x is infinite number of solutions. There's so many answers to this. Anything works, okay? So we're just going to write x is an infinite number of solutions. So all real numbers, anything works. There's how you recognize one like that. All right, I have a couple problems that I'd like you to try on your note sheet, so please try these and we'll check them out in class.